Now we are going to study question from October 2013 exam, question 6. October 2013 exam, question 6. Okay, this is the question that we are going to study now. Okay, October 2013 exam, question 6. Now I am going to read the question, what the question want to say. A 5-meter long ladder, try to see the scenario everyone. What we have? 5-meter long ladder of uniform cross section. Okay, whenever they are saying uniform cross section, it means it will act at exactly at the center of the ladder. Means if the ladder length is 5 meter, where it will act exactly at 2.5 meter, where it will act, and weight will be how much? Mass is 25 kg. See, what they are saying, I am reading once again. A 5-meter long ladder of uniform cross section with a mass 25 kg. So here mass is how much? 25 kg. So then weight of the ladder is how much? 25 g. G stands for acceleration due to gravity. Okay. Is placed with its base on the ground. Try to see the scenario. Placed with its base on the ground and resistance against a pipe. Okay. What they are saying? With its base on the ground and resting against a pipe 1.8 meter from the top of the ladder as shown in figure question 6. Why are they saying figure question 6? See the figure here. Why are they saying figure question 6? Because in that exam it was a question 6. So that's why figure question 6. Figure is given to us in this question. Figure question 6. The ladder makes an angle 60 degree to the horizontal. So here ladder is making how much angle with the horizontal? 60 degree to the horizontal, and coefficient of friction is 0.3 at all surfaces. Okay. Mu is how much here? All surfaces, means here two are surfaces. One surface between the pipe and ladder, and another surface is what? Ground and ladder. Okay. So there are two surfaces, two contact surfaces, and a person of 70 kg is to ascend the ladder. Okay. Try to see the scenario here. Now in A part, what they are asking? Redraw the arrangement showing all of the forces. What they are asking us, guys? Redraw the arrangements. We have to draw the diagram of the ladder and we have to show all the forces, what are the forces acting on that ladder. And the next point is what they are asking us in the B part. Try to see the B part. Calculate the highest point of the ladder that the person of 70 kg mass, 70 kg can ascend. Ascend means it going up. Ascend means what? Going up. Okay, ascend without ladder slipping. Okay, try to see the scenario. I am going to explain once again of this B part, so don't worry. So what we have, guys? This is what a ladder. See the point? Try to see the drawing. Drawings are here very, very important in mechanics. Okay, very. Because if your drawing is okay, then entire question will be okay. Okay, so here we have a ladder. Ladder is resting on what? This is what a ground. Okay, this is what a ground. Okay. Ladder is resting on a ground. Ground is what? Horizontal. So this is what a ground. Okay. So this is what a ground. Then what will be the scenario with us? Here what is there? There will be what, guys? This will be what? A pipe. See the scenario here. This is what a pipe. Okay. See. Base is on the ground. And this is what a pipe. Okay. Now, what is the total length of the ladder? 5 meter. Now, resting against a pipe 1.8 meter from the top. Okay, see. Means from the top, see, from here I am going to draw one dotted perpendicular line. From here also, dotted. See the drawing, So, this distance is how much they have given us in the question? This distance, how much they have given us in the question? 1.8 meter from the means on this pipe. Ladder is how much distance from the, how much distance? 1.8 meter. Okay. So how much? This will be what, guys? 1.8 meter. This distance will be 1.8 meter. Okay. Now try to see the next point. If this distance is 1.8 meter, again from this point I am going to draw one perpendicular line. See, this dotted line must be what, guys? Perpendicular to the ladder. So here from this point also I am going to draw one perpendicular line. Okay. So this distance will be how much? So 1 minute, guys. Let me draw it properly. Okay. So guys, try to see the scenario, everyone. So this distance will be how much, guys? Everyone? How much will be this distance? 3.2 meter. Very good. This distance is what, guys? 3.2 meter. Okay, good. This distance will be 3.2 meter. Then next point. Okay. So entire length of the ladder is how much? Entire length of ladder is 5 meter. So where weight will act? Weight will act exactly at the center. Where it will act? It will act exactly at the center. So suppose this is what? Exactly at the center. And we will say how much mass of the ladder? How much is the mass of the ladder? They have given us 25 kilogram is the mass of the ladder. So how much will be the weight? 25 g. G stand for what? Acceleration due to gravity. So 25 g will be what? And what will be this distance? Everyone, try to see the scenario. Everyone, try to see the point. How much will be this distance, guys? This distance will be how much? Exactly at the center. So this distance will become how much? 2.5 meter. Okay. Everyone, are you getting my point? Try to see the point here. Okay, good. This will be what? 2.5 meter. Then what will be the next scenario? So here what they have given us? Angle between the ladder and the ground is how much in the question? Try to read the question. How much is the angle between ladder and the ground? 60 degrees. See. Okay. Angle between. So this angle will be how much, guys? 60 degree. So this angle is how much? 60 degree. Now there is a person of how much mass of the person? How much is the mass of the person, guys? Read the question. 70 kg. A person whose mass is how much? Guys, 70 kg. Try to ascend the ladder. You got the meaning of ascend. Guys, there are two terms. One is ascend, another one is descend. Ascend means going up. What is meant by ascend? Ascend means going up. Okay. So a person of 70 kg is trying to ascend the ladder. Okay. See, a person of 70 kg is ascending the ladder. We don't know its exact position where it will be. But just we assume it will be suppose somewhere here. We don't know. It can be anywhere. Huh, guys? It can be anywhere. But we just assuming it will be here. So this distance is, so this is what? This weight will be how much, guys? So what will be this weight? 70 g. So weight is how much? 70 g. Very good. So this is what? And see, now I am going to read the B part once again for all of you. See, this drawing means what? What is the meaning of this drawing? This drawing means what? Our part A answer. Huh? What is meant by this drawing? This drawing means what? Our part A answer. Okay, here we have to show all the forces. That is what they are asking. Means in A part, what they are asking us? Redraw the arrangement showing all of the forces. What they are asking us in the A part? Redraw the arrangement showing all of the forces. Okay. Now what they are asking us in B part, guys? Now what they are all of us asking us in the B part? Everyone? Calculate the, see the point? Calculate the highest point of the ladder. See, I am reading once again. Calculate the highest point of the ladder that person of 70 kg can ascend without ladder slipping. Means if the ladder want to slip, how it will slip? It will slip like this. Means ladder motion. Ladder try to move like this. What will happen? Ladder try to move means actually not takes place. Means we want to prevent that motion. So how much distance that 70 kg person can ascend? Means in B part what they are asking us? Calculate the highest point of the ladder that a person of 70 kg can ascend without ladder slipping. See, it means what? How much distance that ladder will ascend means that 70 kg person will ascend. So this distance will, it can be anywhere. And guys, we don't know exactly its location. So what they are actually asking? So we assume this distance as what, guys? This distance, what we will assume? So this distance we will assume as a x. What we will assume this distance as what, guys? X. So in here, in A part, what is our target? Sorry, in B part, what is our target? We have to find out this value of x. Okay. Try to see the point here, everyone. Now, what are the forces here? Remaining forces here, what? Here, what are the remaining forces? See the remaining forces will be what, guys, here? Now, first one is what here? X. We assumed here as a X, okay. This will be X. Okay, is it visible now? X, is it visible properly? Okay, I will make it properly. Anything more which is not visible? Oh, okay, good. Now, how is the motion? Suppose we are assuming this point as a point. We are assuming this point as a point. This point as a what we will assume? This point as a B point. Okay. Now here reaction force will be here. This reaction force will be what, guys? What we will say this reaction force? What we will say? RNB. What we will say? RNB. Now ladder try to move in this side. Ladder will try to move in this side. The friction force will be what, guys? Automatically opposite to the motion. So this will be what, our friction force. So this friction force will be what? How much? We will say FRB. What we will say, guys? FRB. Then there will be what? Normal reaction will be what, guys? Perpendicular to the plane. Normal reaction will be what, guys? Perpendicular to the plane. Try to see the point here, everyone. So normal reaction here. See the scenario here. How is the normal reaction, everyone? So how is the normal reaction? Normal reaction is always perpendicular to the plane. And here in this scenario, the plane is like this. So here normal reaction, and what we will say? This one has a what? Our RNA. Anyone have any doubt in this RNA? Guys, observe this RNA carefully. Everyone. Okay, good. Okay, good. And then what will be the next point? Ladder will try to go down like this, means here. So friction force will be here what? Friction force will be what, guys, here? This will be what? FRA. Okay. Now here I am going to show some angles here for our reference. So from this point I am going to draw dotted line. So this will be dotted line. What about this angle, guys? What will be this angle? What will be this angle, guys? Everyone? 60 degree. Whatever this angle will be same. 60 degree. What about this angle, guys? Everyone? 30 degree. Okay. Drawing is not to the scale. Otherwise you will say, sir, this one is how much? Why 60 degree? It is looking like this. The drawing is not to the scale. Okay. So this is what a 60 degree. This is what a 30 degree. Okay. Now the next point is what? Here we are going to show X and Y direction. So this is what our X direction. And this is what a Y direction. Okay. Now here FRA and RNA will have two components, and showing components here leads to a lot of complications. So how to show the components? So first of all, we are going to show components for FRA. So I am going to draw FRA separately. So this is what a FRA. On this drawing, we are not showing components because showing component on this drawing, it leads to a lot of complications, and we don't like complication. We want simple things. So we are showing components of FRA separately. And how to show the components of FRA? See the point here. I am going to form a rectangle here like this. Here we have shown FRA is going outward. So component will also go outward. Try to see the point, everyone. So this will be one component of FRA. And this will be what? Another component of FRA. Okay. And this angle is how much, guys? 60 degree. So this component will be what? FRA cos 60. And this component will be what, everyone? FRA sin 60. Is it visible to everyone? Try to observe the things. Everyone? Okay, good. Very good. Try to see the scenario. Then next point will be what, guys? The next component will be what? What will be the next component? What will be the next component? Means what? Which force we require next component? RNA. So next force is what? RNA. So here I am showing RNA. So this is what our RNA. And how to get its component? So here we are going to form a rectangle. This is a rectangle, guys, not a square. It may look like a square, but it is a rectangle. Okay. So try to see the scenario. This angle is what? 30 degree. Here force is going inward, so component will also go inward. So here we are showing component like this. So this is what? RNA, what? Cos 30. And this will be what, everyone? RNA sin 30. Okay, good. Try to see the point here. Now the next point is what? Here guys, see, solving such type of numericals, we need such a point where we have to take a moment. Here, which point we will consider for a moment? A point or B point? About which point we are going to, means, see, while taking a moment, we have to select such a point where calculation should be minimum. Guys, listen my words again. For taking moment, we have to select such a point. For taking moment, we have to select what, guys? For taking moment, we have to select such a point where calculation should be what, guys? Calculation should be what? Minimum. Okay, as much as minimum, means as less as possible, means there should be less forces in the calculation or in the expression of moment equilibrium equation. Okay, so which point we will select? A point or B point, guys? And why? Which point? Which point? A or B? A or B? We don't have RNA and FRA also we don't have. See, as you are saying, sir, we don't have a value of FRB and RNB. So that's why we are selecting B point. But here also we don't have values of FRA and RNA. So here, for FRA, RNB, all the forces are unknown to us. But still, why you are selecting B point? Why we are not selecting? Means why we are not selecting A point? Or it is a wrong answer, A part is a correct answer. Or A is correct, B is wrong. Which one is correct and which one is wrong? And why? See, as you are saying, sir, here at point B, these two forces are unknown. But at point A also these two forces are unknown. But here forces are simple. One horizontal, another vertical. But here forces are little bit complicated. One is inclined, sorry, not only one, both are inclined here. But here the story is simple. Then which point we will select? A point or B point? Or B point? Why B point is easier? If A point is easier, then why? Why B point is easier, then why? A point, okay. Now just for, okay, we will see. Which point we will select? Okay, just we will assume, guys, going further before drawing this drawing, which point we will select, okay. Try to see the scenario. B point or A point. Okay, just suppose first of all we will select A point. Summation of moment about A equal to 0, taking clockwise as a positive. Now we will start, suppose we are selecting A point, okay. These two forces will not come into the calculation. Okay, then next force is what? This 25G, and it is distance, suppose we assume it as a x1, okay, from point A. Then 70G, clockwise or anti-clockwise, guys? Clockwise. 70G, this distance we will assume as a x2, okay, this horizontal distance, so x2 we will assume, okay. Then next force will be what? What will be the next force? RNB. RNB will be what? Anti-clockwise, minus RNB, the distance we will assume x2, okay. See, three forces comes here. And then fourth force is what? FRB, minus or plus, clockwise or anti-clockwise? For FRB, guys, moment of FRB about point clockwise, so plus FRB, and distance we will assume as a y1, okay. We don't know exactly x1, y1. If you draw x1 means what? Here, according to this drawing, so this distance will be, no, both are not x2. Sorry, this will be x3. Okay, just x3. Okay. Okay, now it is okay. Just we means from here, from drawing, We can show x1, x2 here. Yeah, okay. So here, how many forces here in calculation? First, second, third, four. Four forces are in calculation. Now, suppose, so here we selected moment about point A. We have considered moment about point A. Now we are going to take a moment about point B. Okay. Now, how to take a moment about point B? Try to see the scenario here. Summation of moment about point B equal to 0, taking clockwise as a positive. So first of all, these two forces will not come into the picture because they are passing through the point B. So what is meant by moment? Moment means what, guys? Force into perpendicular distance. What is meant by moment? Moment means what? Force into perpendicular distance. Guys, try to see the scenario. So here the next scenario is what? So here we will start with RNA. For RNA, what is the perpendicular distance? For RNA, guys, what is the perpendicular distance? See, for RNA, we will get directly perpendicular distance. See, force into perpendicular distance. See, this is RNA. RNA is directly perpendicular to this ladder. So this distance 3.2 will be what? So RNA and perpendicular distance will be equal to what, guys? 3.2. Clockwise or anti-clockwise due to RNA? Clockwise. Okay, good. Now what is the effect of FRA about point B? How to write moment? How to write moment, guys? FRA, I am asking, I am not talking about FRB. See, moment due to FRB and RNB both are 0. So, I am talking about FRA, not FRB. What is FRA? See how it is passing. See this scenario, guys. If you extend this line, it is passing through the point what? B point. See, what is FRA? FRA is, if you extend this line, this FRA is passing through what, guys? Is passing through the what? B point. And if FRA is passing through the B point, then what will be the scenario? Okay, so no moment. So FRA will not come into the picture. Okay. Now what is remaining? So minus 25g anti-clockwise, na guys? Okay, we will assume this distance as a x2 and minus 70g x1 equal to 0. Now here, how many forces? First, second, third. Here how many forces? 4. So out of this, which point we will select, guys? B point. And guys, there is a one more there is one more benefit of B point. What is there one more benefit of B point? What is the one more benefit of B point? Here this distance we are getting directly, guys, 3.2. Means here just we have to calculate this x2 and x1. But this 3.2 we are getting directly this perpendicular distance. So we don't have to do any calculation for this x2 and x1. But here we have to do calculation, means there are 4 terms here, and we have to do calculation for the x1 also, for x2 also, for x3 also, and for y1 also. Means for distance also, for here just we have to do calculation for the 2 distances, but here we have to do calculation for the 4 distances. 4 distances calculation and 4 forces are coming into the moment. So here calculation is more, so difficulty is more. Here, what is the scenario, guys? About B point. Only 3 forces, and out of 3 forces, 1 force distance we are getting directly. So very less calculation. Just we have to do calculation for x2 and x1. Okay. So which point we will select? Now, A point or B point? B point, correct. And why we are selecting B point, guys? Because here only 3 forces, and out of 3 forces, 1 force distance we are getting directly. So just we have to do this 2 forces calculation, this 2 force distance calculation only, this x1 and x2. And so here we are going to show for 25g, what we assumed that distance? We assumed this distance as what? What we assumed, guys? That distance as what we assumed? x2. So this distance will become what? Everyone try to see the scenario. So this distance will be what, guys? x2. And for 70g, how much we assume? This distance is what? x1. Observe this drawing, everyone. So this distance will be what? xy. Everyone, are you getting my point? Try to observe the things here. If you have any doubt, please ask me. Please guys, observe this drawing carefully. Everyone, please try to observe this drawing carefully. Please observe. See, okay, see. Here so what is your question? Your question is what? For 25G, what will be our perpendicular distance? Okay. As you are saying, for 25G, perpendicular distance must be 2.5. That is what you are saying now. Okay. See, what is meant by perpendicular distance? 1 minute. So, as you are saying, sir, why we are not taking directly 2.5? Okay. What is meant by perpendicular distance, sir? See the point here. See, what is our B point? See, here I am just drawing the ladder drawing. Once again here. Only this 2 points. This is what our B point. Then, this is what? This will be what? Our force 25G. Okay. Now, what is meant by perpendicular distance, sir? See, what is meant by perpendicular distance? This 2.5 is it perpendicular distance? What is meant by perpendicular distance, sir? From B point, here we are drawing a perpendicular line. If you remember our moment of force about point O. Okay, so don't get confused. Sometimes we may do mistakes. We will take this 2.5 will be our perpendicular distance. But here this 2.5 is not a perpendicular distance for the 25G. What will be the perpendicular distance for the 25G? x2, 2.5. Okay, guys, are you getting my point, sir? Don't take 2.5 as a perpendicular distance. See, what is meant by perpendicular distance? We covered in our basic theory. Okay, force into perpendicular distance means, suppose, see, I am explaining you once again, so you should not get confused. So, suppose this is point O and this is what a force F. This is what a force. How to get a perpendicular distance, guys? So, this is what a line of action of the force. So, how to get a perpendicular distance from O point? We are going to draw one perpendicular line. So, this distance will be what, guys? Our perpendicular distance D. Okay, are you getting my point? Try to see the scenario here. Okay, force into perpendicular distance. Okay, any more doubt, guys? So, here we are taking a moment about which point? During moment equilibrium equation, B point, and that's why we have taken our distance for 25G and 70G with respect to this B point. Any more doubt? Guys, observe this drawing carefully. Observe this drawing. If you have any doubt, ask me. Okay, everything is okay? Okay, good. Now, guys, what you have to do? Try to draw the drawing properly. That is, this is A part answer. Okay. Don't write anything on this side. I am going to rub these things. Start drawing this drawing, guys. Everyone. So, what is our target here? What is our target in A part? What we have to find out in A part? In A part, what they are asking us? Calculate the highest point. Guys, I am reading A part once again. Calculate the highest point of the ladder that the person of 70 kg can ascend without the ladder slipping. So, this X means indirectly what they are asking us? How much this 70 kg person can ascend without the ladder slipping? Okay. So, what they are asking us in A part? This X distance. Okay. So, what is our target in A part, guys? They are asking us what? They are asking us this X. Okay, what is our target in A part? They are asking us this value of X. And how to get this value of X? Try to see the scenario here. Very, very important discussion. But not that much difficult. This question is simple, not that much difficult. Okay, here I have not mentioned. This force will be what, guys? What will be this force? RNB. And how much coefficient of friction is here? How much is the coefficient of friction here? How much is the value of coefficient of friction? Mu. For 0.3 for all surfaces, means how many surfaces here? 2 contact surfaces at B point and another one is at what, guys? A point. Okay, try to see the point here, everyone. So, try to see the scenario. So now what we are going to do, as usual, our favorite stories start from, in case of such ladder numericals, summation of forces in x direction. See the point here. Summation of forces in what? X direction equal to what? 0. Okay, what are the forces here x direction? What are the forces here in x direction? First of all, what guys, that RNA? RNA what? RNA cos 30. Then what will be the next force? Minus FRA cos 60. See the point here, if you have any doubt. Minus FRA cos 60. What will be the next force? Minus FRB. Okay. Is equal to what guys? 0. See the point here everyone. So RNA cos 30 minus FRA cos 60. Then what will be the minus FRB? Okay. Try to see the point here. So here next point is what? RNA cos 30 minus FRA means what? Mu RNA cos 60. FRB I can shift on that side. So this will become mu RNB. Okay. I can take out RNA common here. So what will inside bracket? Cos 30. See the point here everyone. So in bracket what? Cos 30. Mu is value how much? 0.3. Value of u is how much? 0.3. So 0.3 cos 60 into RNA is equal to mu is how much guys? 0.3 RNB. So RNB will be equal to how much? Cos 30 minus 0.3 cos 60 divided by what everyone? Divided by what? 0.3. So we will get RNB in terms of what? RNA. So everyone please do this calculation. Everyone please do this calculation. Correct? 2.3867 or we can take 68 RNA. So we got RNB in terms of what guys? RNA. What we got? RNB in terms of what? RNA. Try to see the point here. Okay everyone. Please write down up to this point. Please everyone write down all these things up to this point. So now what we got guys here? Now what we got here? We got RNB in terms of what? RNA. What I have written for my reference here. So we got RNB in terms of RNA. Now we are going to take summation of forces in which direction? Y direction. Okay, what are the forces here in Y direction? What are the forces here in Y direction? Everyone. So first of all what we will have? What are the forces here in Y direction? First of all what? This RNA sin 30 plus or minus guys? This RNA sin 30 plus or minus? Plus because it is upward. Okay, plus RNA sin 30. Okay. Then what will be the next point? FRA sin 60 plus or minus? It is upward. Okay. Plus, okay. FRA sin 60. Okay, good. After that guys, what will be the next force? This RNB plus or minus? Plus RNB. What everyone? RNB is how much? RNB is how much guys? Plus or minus? Plus, okay. Then we have this 25G and 70G. Both are the downward. It means what? Minus. So minus 25G. Minus what guys? 70G. And that will be equal to what? 0. Okay. Now try to see the scenario here. Try to see the scenario here. So RNA sin 30. FRA means what guys? mu RNA sin 60. RNB means how much? How much RNB we have written, guys? RNB is how much? 2 point. So we can replace this RNB what by what? 2.38. Check it out, everyone. 2.3868 RNA. And this minus 25G, minus 70G, what will become? Minus 95G, and if you are shifted on this side, it will become plus 95G. Check it, guys, everyone. Any doubt in this discussion? Okay, good. Now, what is common in each and every term here? What is common here? RNA is common. So, I am going to take out common RNA. So, what will remain? Sin 30 plus mu is how much, guys? For each and every term, means for each and every surface, 0.3. So, 0.3 RNA. Please observe, guys. Sorry, we have already taken RNA common. 0.3 into sin 60 and plus 2.3868 and into RNA. Okay. Is equal to what, everyone? 95G. Okay. Any doubt in this discussion? Please try to observe these things, everyone. So please everyone calculate this term in bracket. Please do the calculation with me, everyone. No, check it once again. Three point 3.1466, okay, correct, into RNA. Everyone getting this answer? Check it, guys. Okay, let me know. There may be a mistake from my side also. Okay, so RNA is equal to what? 95G. We are not going to put the value for G. We are keeping G as it is. Okay, divided by what? 3.1466. So we will get RNA in terms of G. So 95 divided by what, everyone? 95 divided by 3.1466. 30.19 into G. Okay. So please, so we got it. We got what we got, guys? RNA in terms of what? G. I am writing for my reference. So 30.1913 G. Okay. Here this I am writing for my reference. Please everyone write down all these things. Okay. We have written already target. Don't write down target. Start writing down from summation of forces in y direction. Please everyone write down. So what we got, guys? We got RNA in terms of what? G. Okay. Now what we are going to do? We are going to cancel G in the future. Okay. Now we are going to take a moment about what point? About which point we are going to taking a moment here? About which point we are going to take a moment here? A point or B point? In the beginning of this questions we discuss about B point. Okay, we have a lot of benefit of taking moment about B point. So here we are going to take a moment. Summation of moment about which point? Everyone? About B point equal to 0. Summation of moment about B point equal to 0. Taking what? Clockwise as what, guys? Positive. Taking clockwise as what? Positive. Okay. Now here RNA. What is the effect of RNA about B point? Clockwise or anti-clockwise? See, this is a B point. So effect will be clockwise. What will be the perpendicular distance for RNA? Perpendicular distance will be this directly 3.2. Observe this point, everyone. So here we are getting direct benefit. Okay. So RNA into perpendicular distance is how much, guys? Everyone. This perpendicular distance is how much? 3.2. Then the next force will be what? 25G plus or minus. See. Now what about this FRA? FRA is what? Effect of FRA about point B. Moment of FRA about point B is 0. And why 0? Because FRA is directly passing through the point B. See, if you extend that one, FRA is directly passing through the point B. And if any force passing through any point, perpendicular distance will be what, guys? Perpendicular distance will be what? 0. Perpendicular distance will be what? 0. So there is no moment of FRA about point B. Okay. So this will not come into the picture. FRA will not come. FRB will not come. RNB will not come into the picture. For all these three forces, perpendicular distance is what? 0. The next force is what, guys? 25G. What is the effect of 25G about point B? What is the effect of 25G about point B? Clockwise or anti-clockwise? Anti-clockwise. Very good. Minus 25G. Perpendicular distance will be how much? X2. Then 70G again anti-clockwise. Minus 70G. Perpendicular distance will be what, guys? Everyone. Into what? X1. Very good. Equal to what? 0. Only these three pictures. These three forces, RNA, 25G and 70G. These three forces will come into the picture. Now here this X2 and X1 is unknown to us. This X2 and this X1 is unknown to us. So for this purpose, what we are going to do? So we have this angle 60 degree. 60 degrees. This is what? X is what? Hypotenuse. X1 is what? Adjacent. So adjacent and or we can say base also, no problem. So adjacent and hypotenuse. What is the relation? Cos. Okay. Okay. So what? Cos 60 will be equal to what, everyone? Cos 60 will be equal to what? Adjacent X1 by X. X1 by X. So X1 will be equal to what? X cos 60. And what is the value of cos 60, everyone? What is the value of cos 60? Please do the calculation and tell me the value of cos 60. 0.5. So we can write down X1 is equal to what? 0.5x. So we got X1. Then similarly we are going to do the calculation for X2. For X2 again same. Here X2 is what? Adjacent, and for their corresponding is what? 2.5. So what will be the scenario here? Cos 60. Please observe this scenario. X2 by what, everyone? 2.5. X2 by what, everyone? X2 by what? 2.5. Okay. Visible to everyone properly? Okay. So X2 will be equal to what? What will be X2? Okay, X2 will be equal to 2.5 into cos 60. So what will be the value of 2.5 into cos 60, everyone? 1.25. Unit will be what? What will be the unit? Meter. Meter, okay. Distance, here all distance. So we got here, everyone, try to see the scenario. We are nearer to the answer. So RNA we got how much? How much we got RNA? So here how much RNA we got? 30.1913 G into 3.2 minus 25 G. Everyone observe the scenario. X2 how much we got? 1.25. Okay. Clear, everyone? Observe the things, everyone. 1.25. Then what will be the scenario next? Minus 70 G. X2 will be, X1 will be how much? 0.5x. What is common in each and every term here? What is common in each and every term? G is common. G is, and if you take out the G common, guys, if you take out the G common, what will happen? We can take out G common and 0 and going to take G on this side. So 0 divided by G is how much? 0. So we can cancel this G. Any doubt in cancellation of this G, everyone? We can take out G common and we are going to shift on this side. So 0 divided by G will be how much? 0. So the G will get cancelled. Then what will be scenario? Our target is what? So 30.1913 into 3.2 minus 25 into 1.25 is equal to how much, guys? 70 into 0.5 into x. I have shifted on that side. Okay. So please everyone do this calculation for this part. Everyone please do the calculation. 65.36216. Check it out. Okay, is equal to what, guys? 70 multiplied by 0.5, how much? 35 into your, okay, so what will be the value of x? Everyone, please do the calculation of x. 65.36216. 1.8675. Okay, 1.8675, and unit will be what? Meter. Okay, okay, everyone, are you getting my point? Say the scenario here. So what they are asking us in the A part here? What they are asking us in the A part? In A part, they are asking us this x. Sorry, what they are asking us in the B part? In the B part, they are asking us this distance x. And here see, whatever the position of 70 kg mass we have mentioned, it is correct. It is below the 2.5. So our answer is what? So means whatever we assumed, guys, this 70 kg mass can be anywhere, but we assumed here it is below, and our assumption is correct. So here it is coming below the 2.5. So x is what? Okay, everyone getting my point? It can be anywhere. So initially we don't know exact its position. Now we know it is below 2.5. So here initially we assume, and our assumed position is okay because it is below the 2.5. Okay, anyone, any doubt in this discussion? Okay, good. Okay, so now what our target? So what you have to do? Just write down all the things properly. If you have any doubt, ask me. Okay, please everyone write down these things.